Hi, Bruce Hanson here. I'm an electrical technician for Nucor Steel, Utah, and tonight I'm going to show you how to troubleshoot some of your home appliances that may not be working, rather than call a repairman or just throw them out and buy a new one. There's a few things that you can do before you do that. Even some of your home circuits, if you're comfortable with working on 110 volts. First thing you'll need though is a multimeter. I have a couple of different options. First one is a Fluke. This is an industrial meter. It will read up to 1,000 volts and several hundred amps. I've read 500 amps, which is a lot of amperage. You will never find that in your home. This is a very excessive meter. You will not use this to the extent of its capabilities in your home. This is a very good meter, very cheap meter. It's actually free. You get a coupon from your Harbor Freight coupon. Go and buy something and they'll give you this meter for free. It'll work for most home appliances. It will not work if you're trying to check something that'll run over 10 to 15 amps. It has a 10 amp rating. Now, your amperage is just the current that's being used. Gives the punch for the voltage. So, a few things that I've got here on display are a bag sealer. We'll go through and troubleshoot that right now. I have it unplugged from the wall. And there's a couple different components to this. It has a switch. The switch on this is inside the arm, so that when it's up, nothing is going to go through the heating element. When it's down, that switch closes and then allows the power to go into the heating element to heat up this bar right here. So, first thing you do is turn your meter on. And we're going to select ohms. That's the symbol for ohms right there. And that's how we check continuity through a circuit. So we're going to select 200 ohms, and then we're going to hook it on. First we'll test it on the leads. So right now we're reading 2.5 ohms, 2.4, 2.3. That's very low ohm reading. That means your meter is working. Almost no resistance between these two leads right here. So we're going to check it between the power and the neutral, and we're still reading nothing. Now, it shouldn't read anything until that switch is down. We're still not reading anything, so that tells me that we have an open somewhere in that circuit. Most appliances have a circuit breaker or a fuse. This one has a fuse, and I actually have it pulled out. The fuse is right here, so we're going to go ahead and put that fuse back in and check this circuit again. Okay, now we'll engage the switch, and I am reading 6.8. That's pretty accurate for what that heating element should be. Should be just a little bit of resistance there. So when that fuse blows, if that fuse goes out, you can tell that with this current reading. You won't show any ohms, any resistance through that circuit when it's completed, because that fuse has opened up. The second thing I have is a fan, and we're going to do the same thing to this fan. This one we're showing resistance on right now, 74. That means that it should run as soon as I plug this in. Pull this over here. So I have that switch in the high position. You can't really see it, but that's high. So if I switch that to medium, our ohms go up in value. Now we're reading 125 ohms. So we got a greater higher ohms. I put it to low, and now we're reading 155.5. So that means that we have different resistances in this switch. The higher the resistance, the less power gets to the motor and the slower speeds. The lower the resistance, the more power we get to the motor and the higher speed of the fan. And so we have different resistors on each part of these switch. Now when we go to the off position, again, we're not showing anything over here on this side. So that means the circuit is open. Now if you were to do this switch and it did not change, that would most likely determine that your switch is bad. And the final thing, both of those were AC current, AC voltage. The final thing I've got here is a laptop cord. Now say you plug in your laptop to this cord and it's not charging. What do? How do you find out if your laptop's broke or you're not getting the power through this cord? Well, you can do that with this meter. So what you're going to do is, your wall outlet is AC voltage, but most of your small devices such as laptops or cell phones have these power inverters. It means that it's taking it from 110 volts, and in this case we're dropping it down to 20 volts, 3.25 amps. And that you can read, you won't be able to read it here, but if you look close enough on any of your plug-ins for your cell phone or your computer, it'll tell you what you're looking for, what it converts it to. So we need to find there's 20 volts. Now that's the max range for this setting. So we're going to actually go to 200 volts DC, and it says DCV, direct current voltage. Now we're going to take our red lead, which is the positive, we're going to put it on the pin in the center. And then our black lead, we're going to put it on the outside. So you get the black lead on the outside of the plug. It's hard to see. And then the red lead on the pin in the center of the plug. That's where your positive power is. And right now we've got 20.7, 20.9, 21 volts to charge your computer. So that means your computer power adapter probably has gone bad. There's a fuse inside of there on the circuit board. And it could be several other things if your computer is not charging. That's beyond the scope of this video. So in conclusion, this little tool right here can save you a lot of time and a lot of money wondering what is wrong with a lot of electrical components. And there's a lot more that we didn't even touch. All we did is checking our voltage in the device, making sure we had voltage. And another thing to just to check is, do you have power coming out of your outlet on your wall before you deem the device that's not working bad? Because a lot of times your circuit breaker down on your panel in your house will not be working, and that's the issue with a lot of things. So like I said, in conclusion, this multimeter is a necessity for troubleshooting, and they are wonderful devices. I highly recommend do-it-yourselfers to have one, and you can even double check what other people that you hire to come in and give you an opinion. You can double check that they're being accurate in what they're telling you. So I hope it was helpful, and we'll see you guys later.